Hello, friends. Welcome to the third installment of the math review for math review for physics, and it's time to go over everyone's favorite math, geometry. Yay! So I like to think of physics as spicy math, right? In physics, we quantify the world around us, right? We apply math to find an answer about a phenomenon. If you end up going really into the sciences and especially like into physics, you'll find that you also use a lot of other types of math. But for this class, we're mainly going to use a couple of major geometry topics. One of those main topics is SOHCAHTOA, right? So using sine, cosine, and tangent to find certain values that make up a triangle, because you're actually going to find that a lot of the world around us deals with intersections that form triangles. Y'all, you gotta be familiar with and comfortable with defining which trigonometric function you need to use, sine, cosine, or tangent, and also which sides of the triangle you're using. Okay, let's go through an example. I know that using some of these trig functions can seem a little scary at first because for the most part, up to this point, really we've only had to use these in like a math problem, right? But again, physics involves math, so we just got to get comfortable with it. Okay, let's look at this first example. So I put my dogs in a cart and I push them up a hill. The hill is 10 meters high and the angle up the hill is 23 degrees. What is the distance I push them up the hill? Let's draw a picture first, right? Let's see what's going on in this scenario. Okay. So I know I've got a hill, right? So I'm pushing my dogs. Pretend that's my dog. I'm pushing my dogs up a hill. I am told that the hill is 10 meters high and that this angle is 23 degrees. I'm asked to find this distance x. How far do I actually push them? So I want you to think in your head. What do I know? What am I being asked for? I know this angle. I know opposite. And I'm being asked for hypotenuse. So what does that look like? I hope you said that looked like the sine function, opposite, hypotenuse. So what I know is sine of some angle, and I'm going to use the symbol theta for that, is equal to opposite over hypotenuse. So I'm going to plug in values. So sine 23 equals 10 meters over hypotenuse. I am solving for the hypotenuse. So I'm going to do some algebra. I'm going to move hypotenuse over and sine under. So I end up with x, the hypotenuse, is equal to 10 meters over sine 23. Okay? So I'm going to put that in my calculator, and I get that I pushed them approximately 26 meters. See how I rounded it? And it was fine, right? Approximately 26 meters. Push my dogs a long time. So these are the functions that you need to feel comfortable working with. Basically figuring out where's the angle perspective, what am I being asked for? Okay, last example for this. Given the following map, which I will draw in a second, what is the length of side Z? So again, for a lot of these types of problems, we're going to be dealing with triangles because think about it. Let's say that you You start at point A, and you walk to your friend's house at point B. Then maybe you go visit your grandma at point C. We're going to see later on that this distance, this displacement, how far you really walked, is important. So this is side Z. So let's say that this triangle has the following sides. Okay. Let's say this side is 5 meters. You live very close to your friend. Your friend only lives 12 meters away from your grandma. So if you remember your ratios for your triangles, this is a 5, 12, 13. But if you don't remember that, good old Pythagorean theorem is our friend here. So 5 squared plus 12 squared equals c squared. We solve for c, we get 13 meters. So this is the extent of the geometry that you really need to be familiar with. Okay, friends, this concludes the geometry review. As always, I suggest that you go work on the geometry review problems now while it's fresh in your mind. And as always, if you have questions, please feel free to reach out.